Today we're going to start talking about measures of center and spread, and then on the second page of the notes we're going to look at normal distribution. So let's start with those measures of center. We've got mean. Hopefully you recognize that one as being the average of a data set. You would take the sum of all of your data and divide it by the number of values that you have in your data set. I did circle the symbol there with the X with a line on top. That's our symbol for mean, and we're going to be using that symbol a lot to represent mean in our following questions. Median, another measure of center, is your middle term when your data is listed in order from least to greatest. If there are an even number of data, then you would take the average of the two middle values to find your median. So those are two measures of center, mean and median. Measures of spread, how we can describe the spread of our data. We can use standard deviation. This might be a new one for you. And its symbol is a Greek letter that looks like a circle with a little hat on it. That is the average distance each value is away from the mean, is standard deviation. So you would have to know your mean and then how far away every value is, then take the average of that. So if our standard deviation is small, it means that our values are very close together or close to the mean. If our standard deviation number is larger, our data is more spread out and farther away from the mean. Another measure of spread you might be familiar with is interquartile range, or abbreviated as IQR, and that is the difference or range between our upper quartile and our lower quartile, our Q3 and our Q1. So this comes from our box and whisker plot. Might have been a minute since you've seen a box and whisker plot, so I'm going to draw one right here. And our box and whisker plot, the left lower side here, that's that first quartile or lower quartile. And then the right side of our box is our third quartile or upper quartile. So if we are going to take the difference of that first quartile and third quartile to find our IQR, it's going to represent 50% of our data because a box and whisker plot divides our data into quarters or quartiles or 25%. So when we subtract our Q3 and Q1, that's going to show 50% of our data. Right below, I have an example of a list of data that represents the ages of random sample of 16 people who visited the doctor's office one day. And we're going to find each of the following statistics. Starting with that X bar, I want to remind you that that represents our mean. So we'll find our mean. This next symbol, remember that stands for standard deviation. We'll find our IQR and our median. Now, this could be a lot of work if we were doing it by hand. Mean, not so bad. Standard deviation, though, that would take a lot of work. We would have to find our mean. We would have to find the distance or the range every value is away from the mean, and then average those distances. So it would take a lot of work. Below, I've got calculator steps and calculator symbols for most of these things. Notice the output there on the right. You're going to get all of that information on your TI Nspire once you load this data in. That's way more than I would ever need, but it does contain my mean. It will have my population standard deviation, and then I can use my first quartile and third quartile to find that IQR, and we also have our median. So you'll get all of that information, not all of it we will need. So let's grab our calculator and let's load this example in to our calculator and get these statistical values. All right, from the home screen of our Nspire, we are going to use a list in spreadsheets. A couple of ways you can get there is you can come down here to the apps at the bottom, and that center one is list in spreadsheets. If you want to navigate there, that's where we're going. Or from a new document, here we also have, instead of adding a calculator or graphs, you can add list in spreadsheets. So we're going to list all of our values into column A, starting with 82, 73. Now you can type these in and then use the enter button, or you can arrow down, whichever you prefer to get to the next box. 80, 52, 78, 64, 70, 80, 78, 35, 78, 74, 80, 75, 62, and 80. Okay. I've added those all up. Our example did say it was a sample of 16 people. When I look at my calculator, my last entry was on line 16, so that's a great place to check and make sure you didn't skip any. Once you are out of your data, make sure you're in an empty box. Hit Menu. We're going to go to Statistics. stat calculations, and one variable statistics. We just entered in one column of data, like one set of X values, not two. We weren't comparing X's and Y's. So I'm going to use one variable statistics. You're going to get two pop-up boxes, neither of which we need to change anything. Use the tab key to get you to OK, because if you just arrow down, your drop box is going to change there. So the next two pop-up boxes, you're just going to hit OK. You're not going to need to change anything. Here's the second pop-up. I'm going to use tab to get down to OK. So you're going to have tons of statistical information purposely on our notes here. The last step on our calculator steps, I put arrow up to see it all. We are actually looking at my screen at the bottom, or the last statistical measure it's going to give me. Arrow up, there is so much more. Just where we entered so much data, it starts to load at the top. And so we only saw that last bit. This is exactly like the list of symbols I have on your notes, starting with the X bar for the mean. So this is our example. Let's fill it in. The mean for this data set is 71.3125. For our notes, let's just round it to the nearest hundredth. So 71.31. Arrowing down, there's a lot of information that we don't need. So once we get to that OX looking symbol, that's our population standard deviation, 12.2664. Let's round that also to hundredths. So 12.27 is our standard deviation. So remember, standard deviation is the average distance every value is away from the mean. So on average, most of the data values are 12.67 away from the mean. Now, IQR is not specifically on here, but we are given Q3 and Q1. So let's arrow down. Here's Q3 is 80, Q1 is 67. I have to subtract it myself to get that IQR. So subtract 80 and 67. We're going to do Q3 minus Q1, 80 minus 67, or our IQR is 13. Back on the calculator, we do have median listed, 76.5. So I wanted to switch for a quick minute and look at a problem that you're going to have on Delta Math. Notice Delta Math is going to provide you with the calculator output just like we just got on our calculator, those one variable statistics starting with the mean and all the additional information. And you're going to have different questions asked. This first one, as an example, is determine the interquartile range. So it's more or less a question of, can you interpret the symbols and come up with the statistical value that's being asked? So interquartile range, you would use the given Q3 and Q1, subtract that to get your IQR. That's what the Delta Math is going to look like. Moving over to page 2, we're going to focus on normal distribution. Most statistics gathered in the natural world tend to have a normal distribution with a symmetric bell curve centered on the mean. So most of your data is going to fall around the mean and then slowly taper off is what that means. Now, for all normal curves, they have the following properties, sometimes called the 68-95-99.7 rule or empirical rule. Sometimes our EOC questions mention the empirical rule, so that can be a clue that you're using this 68-95-99.7 rule. And it means that 68% of our data is going to fall one standard deviation above and below the mean. 95% of our data is going to fall within 2 standard deviations of the mean, above and below, and then 99.7% of our data is going to fall within 3 standard deviations of the mean, above and below. So I want to remind you of some symbols. Remember, in our earlier lessons, we were talking about population mean, and then we just talked about standard deviation. So I want to list those symbols above because they are used in the illustration. So notice on the illustration at the right, we've got that U shape with that tail for population mean. That's my mean. And then to the left, this is our mean minus 1 standard deviation. To the left, we've got another mean minus 2. And then out again, our mean minus 3 standard deviations. The other side, adding 1, adding 2, and adding 3 standard deviations. Notice 68% is adding and subtracting 1 standard deviation away. 95% is how much data would be if there is adding and subtracting 2 standard deviations away, and 99.7 if you add and subtract 3 standard deviations away from the mean. There's another illustration below, just if it's broken up a little bit differently. Still has the same information, just if each half was broken up. I'm still showing 68% here, but one half of that to the left would be 34% and the other half another 34%. Sometimes our EOC questions won't be necessarily centered and we might have to add a smaller section with a bigger area. So I wanted to make sure you had this reference. Same here as well for our 95%. And then lastly, from our threes, adding and subtracting 3 standard deviations, 99.7% of this data. Just wanted to make sure you had plenty of references on what percentage of data would fall within our bell curve in our normal distribution. So let's look at some examples. Number 1, in an all-boys school, the heights of the student body are normally distributed with a mean of 71 inches and a standard deviation of 4.5. So I'm going to go ahead and label our mean was 71 inches and our standard deviation was 4.5. Just making notes here. Using the empirical rule that 68, 95, 99.7, determine the interval, that's what we're trying to get to, of the heights that would represent 95% of the male heights in this school. So we're trying to write an interval for 95%. 95% is when I add and subtract 2 standard deviations from the mean. So if our mean was 71 and I subtracted 2 standard deviations, that would look like 71 minus 4.5 and a second 4.5. That would give me 62. So we're looking for this area here, 2 standard deviations away on each side to represent 95%. I know the lower side is 62. What if we add 2 standard deviations? Adding 2 standard deviations is going to add up to 80. So our interval that we were looking for, 62 to 80. Let's try a second one. When Ryan runs the 400-meter dash, his finishing times are normally distributed with a mean of 75. I'm going to go ahead and label that here on our bell curve, with a standard deviation of 0.5 seconds. I'm going to make that note. Using the empirical rule, determine the interval of times that represent the middle 68% of his finishing times in the 400-meter race. 68% is equal to adding, subtracting 1 standard deviation from your mean. So let's take our mean, 75, and add a standard deviation. And we'll also take 75 and subtract a standard deviation. That will give me the upper and lower side. That would include 68% of our data. 75 plus 0.5 is 75.5. 75 minus 0.5 is 74.5. So there is our interval, the 74.5 to 75.5. Let's try number 3. IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. I'll make a list here of our notes. Standard deviation 15. Using the empirical rule, what percentage of people have an IQ score between 55 and 145? So that's our interval, and we're now working backwards to find what percentage. In order to know what percentage, I need to know how many standard deviations we are away. So I like to sketch this out. I know my mean is 100. Let's subtract a standard deviation of 15 would give me 85. Not quite 55. So let's subtract another standard deviation of 15, gives us 70. Let's try one more time, subtract a third standard deviation. Yes, gives us that 55. What about the upper side? Let's add a standard deviation, 115. Add a second, gives us 130. Adding a third standard deviation does give us that 145. So we were 3 standard deviations away on each side. We had to add or subtract 3 standard deviations away, which is 99.7%. Let's try a similar question. Number 4, At a local restaurant, the amount of time that customers have to wait for their food is normally distributed with a mean of 26 and a standard deviation of 5 minutes. Using the empirical rule, what percentage of customers have to wait between 21 and 31 minutes? So I like to do the same thing. I like to sketch it out. Our mean is 26. If we subtract a standard deviation of 5, that's 21. Oh, that's what I need. Let's check the other side. Adding one standard deviation, 26 plus 5 is 31. So we had to add or subtract one standard deviation away from our mean to get those values of 21 and 31. One standard deviation away on each side encompasses 68% of our data. For number 5, on a test that has a normal distribution, a score of a 33 falls 2 standard deviations below the mean, and a score of 63 is 1 standard deviation above. Let's sketch this out. I don't know what my mean is. That's actually my question. Determine the mean. So let's sketch it out. I don't know the mean, but I know 33 is 2 standard deviations below, and 63 is 1 standard deviation above. So we're trying to determine that mean. In order to know the mean, I need to know what our standard deviation really is. So let's subtract. Let's find that range between 63 minus 33 is 30. And then between these values, we had 1, 2, 3 standard deviations. So take your 30 and divide it by 3, gives us 10. 10 is our standard deviation between each of our values. So you could do 33 plus 10 gives you 43, plus 10 gives you 53, and you can see plus 10 gives you that 63. Our mean was 53. Let's try again with number 6. On a test that has a normal distribution, a score of a 34 is 3 standard deviations below, and then a score of 59 is 2 standard deviations above. Determine the mean. So let's sketch it out. I don't know the mean. 34 was 3 standard deviations below. 34. And 59 is 2 standard deviations above. Okay, so just like we did on the last problem, I'm going to find the distance or the range between the values that I do know. 59 minus 34 is 25. We have 1, 2, 3, 4, 5 standard deviations between. I'm going to do 25 divided by 5. Our standard deviation is 5. So if I add 5, that gives me 39. Add 5 gives me 44. Add 5 gives me 49 is my mean. I'm just going to keep checking. We get a 54, and if I added 5, I'd get 59. So our mean was 49. So recall we started at the very beginning of the notes looking at mean, median, standard deviation, and IQR, and we walked through the steps for the TI Inspire to load data in and then get that statistical information, practice that, and then normal distribution, learning that 68, 95, and 99.7 empirical rule to help us determine standard deviation, means, and intervals using that empirical rule. Practice that, guys, and let me know if you have any questions. I'll be glad to help. I'll see you in class.